Are electric cars really better for the environment? Is there enough lithium and other rare metals to meet demand for battery production? It is widely reported that the global supply of lithium-ion batteries is struggling to keep up with the increased demand from electric car manufacturers. Globally, both battery production and the production of lithium and other precious metals is being ramped up rapidly. Is this good for global warming? Shouldn't we look at the electric car's whole life cycle impact on the environment? So we ask again, are electric vehicles really better for the environment? Find out on Amir Phillips' American Pragmatist.
Ignoring all of the remedies, believing all of the rumors, with their endless database. I wanna sit with my enemies and say we should have done this sooner, while I look them in the face. Maybe that will crack the case.
Hey Amir, I want to talk about electric cars and the Green New Deal, and I'm curious what's making the Green New Deal viable?
There was a technological revolution behind the green energy shift that's now advocated all around us by mainstream media. And this tech revolution is most aptly revealed by the electric engine, which has already made humanity more prosperous than the Green New Deal, a plausible hypothesis.
Okay, taking a step back, is there anything in particular in running these electric engines which is also needed to run the Green New Deal?
Yes. These electric engines run off electric batteries that create the electricity needed to activate the magnets. The difference now is that with rare metals, it's possible to generate clean energy since they cause the rotors of, say, wind turbines to turn and convert into electricity. Because these magnetized electric engines remove pollution from most, not all, but most of the energy cycle from manufacturer to final end use by consumers, we can now possibly envision a world with greatly reduced oil-fired or coal-fired power plants.
Okay, and what, pray tell, is behind the magnets that run the electric engines and make the Green New Deal a realistic possibility?
These super magnets are produced with the rare earth minerals neodymium and samarium that are alloyed with other metals such as iron, boron, and cobalt. Magnets are usually 30% neodymium and 35% samarium. For the sake of clarity, they are more commonly referred to as rare earth magnets by the scientific community and are so critical to our future that we have a separate podcast on the accelerating use of these rare earth elements as part of the new global economy.
Okay, Amir, do all electric cars have these critical rare earth magnets?
Not all. The electric cars of Toyota, Nissan, Mitsubishi, General Motors, PSA, and BMW do contain rare earth magnets, but others have done without them, such as U.S. manufacturer Tesla's squirrel cage induction motor car and Renault's rotor coil engine Zoe. Nevertheless, these two are bigger and heavier than engines using rare earth magnets.
Earlier you mentioned the turbines. Do the wind turbines all have the rare earth magnets?
In 2016, 7 of the 10 most powerful wind turbines were made using rare earth metals. The V164 by Vestas, the AD180 and ADS135 by Adwin, the SWT 8.0 by Siemens, the 6MH Heliade by General Electric, the SCD 6.0 by Minyang, and last, the Dongfang / Hyundai 5.5 MW.
I don't really know what language you're speaking right now, but it sounds like you're saying all of them.
No, I know I gave that impression, sorry about that, but the answer is no. German wind turbine manufacturer Enercon opted for separately excited annular generation as it claims that it is possible to do so without permanent magnets. So my answer to your question, it's pretty much all, or let's go with a heck of a lot.
Okay, to be clear, these electric engines, they run off of electric batteries. The batteries create electricity that's needed to activate the magnets. The difference, however, is that with the rare metals, it's possible to generate a cleaner energy?
Yeah, dead on, Jamie, that's correct.
Okay, so how is that happening?
They cause the rotors of the wind turbines to turn and convert the sun rays into electricity using solar panels, especially solar panels made from copper, indium, gallium, selenide, CIGS, solar cells. And because they remove pollution from most of the energy cycle from manufacture to end use, we can safely envision a world with greatly diminished oil-fired or coal-fired power plants.
And this must be why there's all of a sudden concern for rare earth magnets.
Yeah, I believe that's why. To be clear, most electric engines in operation in the world today work by induction and therefore do not use rare earth magnets. These engines used mostly in heating, ventilation, air conditioning devices. They're inexpensive, but also low performance. Most electric engines are not heavy hitters, but electric cars need a heavy hitter electric engine. And in general, industrializing high performance electric engines do use rare earth magnets. And specifically, this is the case for the electric engines used in electric vehicles, electric cars, and certain wind turbines. So, given the world demand for ever higher performing electric cars, you can see the sudden structural global concern for rare earth magnets.
Yeah, you're making me realize we're going to need a lot of these magnets because, the higher demand for the electric cars, it's the car of the future, so that's going to lead to more rare earth magnets being used in the engines. And then the bigger electric engines, like the wind turbines, if they can compete against the huge fuel engines used everywhere, all over, the rare earth magnets will become even more critical to any nation's economic development for economic growth. Is that a fair assessment?
That actually was very good, very fair, dead on.
Oh man, we're going to need to get to work on these. There's always on American Pragmatist, we reveal a dark side to everything. So what's the dark side of this issue?
Unfortunately, in socioeconomics, everything has a cost. So yeah, there is a dark side. The pollution caused in the mining of the rare earth magnets is huge. Their extraction is environmentally ugly, real ugly.
Is it emanating from any particular area?
Communist China.
I should have known your answer.
That's right. But the mining of rare earth metals concerns all mining countries, not just Communist China, the main ones, such as Democratic Republic of Congo, which supplies more than half the planet's cobalt. That resource, cobalt, is indispensable to lithium-ion batteries used in electric vehicles and is mined under conditions straight out of the Middle Ages. 100,000 miners equipped with spades and picks dig into the earth to find the mineral, especially in the southern region of Lualaba.
Can the governments of the world regulate more mining so that it can be done properly?
It hasn't been happening. It's certainly not happening in the Congo, and the pollution of the surrounding rivers and turmoil in the ecosystems are legion, well discussed even in mainstream media. Research by Congolese doctors has found that the cobalt concentration in the urine of the local communities living near the mines of Lubumbashi in the Katanga province is up to 43 times higher than a control sample.
Wow. I remember reading somewhere that somewhere in Latin America, they've already started to have some of these problems with the lithium mining.
Yeah. Lithium is a white metal lying below the salt flats of Bolivia, Chile, and Argentina. It is considered critical by the United States, and demand is expected to soar on the back of the electric car boom.
So outside of those countries, has there been a mad dash for lithium?
Argentina already has its sights set on becoming the giant of lithium, and between now and 2025, not too far away, Argentina has the capacity to produce up to 165,000 tons a year, or 45% of global demand, provided it can get foreign investors on board.
This is a good industry for a lot of these countries. Why has it sparked such an environmental activism?
Yeah, as with any mining activity, it requires staggering volumes of water, diminishing the resources available to local communities living on water-scarce salt flats. Already, the communities of the Hombre Muerto salt flat in Argentina blame lithium mining for contaminating their streams, and arguably rightfully so.
Okay, so, wow. If extracting minerals from the ground is such an inherently dirty operation, doesn't this cast doubt on the virtuous vision of the green energy, the digital transition espoused so often by, I remember his name, Klaus Schwab, is that the guy
Klaus
you're
Schwab
talking
is
about?
it.
Yeah, in the fourth industrial revolution or something like that.
Yeah, I think that's pretty darn accurate there. And a recent report by the Blacksmith Institute identifies the mining industry as the second most polluting industry in the world, behind lead battery recycling and ahead of the dye industry, industrial dump sites, and tanneries. It has moved up one rung since 2013 rankings, in which the much maligned petrochemical industry, oil and gas industry, frackers didn't even crack the top 10.
So from what you've talked about so far, it feels to me like the conventional fuel-based cars are really, they're no worse on the environment than the electric cars.
Yeah, well, there is science to back up the claim you just alluded to. In 2012, researchers at the University of California, Los Angeles, UCLA, compared the carbon impact of a conventional fuel-driven car against that of an electric car, head-to-head competition. Their first finding was that the production of the supposedly more energy-efficient electric car actually requires far more energy than the production of the conventional car. This is mostly on account of the electric car's heavy, very heavy lithium-ion battery.
So far, you were saying the other day that Tesla has been exempt from the rare earth magnets. Is that also true of the lithium battery issue?
No, it is not. The battery in Tesla's Model S, for instance, weighs in at 544 kilograms, or 25% of the electric car's weight. Wow. Then, and on top of that, there's the composition of the lithium-ion battery: 80% nickel, 15% cobalt, 5% aluminum, as well as lithium, copper, manganese, steel, and graphite are all in there.
That's a lot of minerals that need to get mined from worldwide, I guess.
Not just a lot of minerals, Jamie, that need to be mined. They need to be refined. Not just mined, but refined, and that's a critical component of the analysis. You got to reconsider how these minerals are refined, not to mention the logistics of their transportation and assembly. The UCLA researchers reached the conclusion that industrializing electrical vehicles is 3 to 4 times more energy intensive than industrializing conventional cars. But to be fair, looking at its end-to-end life cycle, however, the electrical car has the undeniable advantage of not requiring petrol or fuel. This brings down its carbon dioxide emissions to 32 tons from factory to scrapyard, compared with almost double that for the conventional fuel car.
One thing I really like about talking with you is, like, no matter what the topic is, you seem to do a lot of research, but then you also kind of push back on some of the research, and you find holes and weaknesses. In this issue, like, have you been able to find any problems with what you've read so far?
It is. I mean, it is in a sense. Normally you do have to qualify the research. There's no all good. In this case, the caveat of this research is that it was conducted on a medium-sized electric vehicle battery with a 120 kilometer range in a market that is growing so fast that none of the electric cars being rolled out today have a range below 300 kilometers.
So does that affect the result of the UCLA research?
In my mind, and I normally do punch holes in research and I normally qualify it, but in my mind, in this case, it actually augments its findings, the UCLA findings, since a battery that is powerful enough to drive an electrical vehicle for 300 kilometers emits twice as much carbon as production phase emissions, a figure we can then triple for batteries with a 500 kilometer range.
Okay, so we can pretty much conclude that over the entire lifespan of an electric car, it may produce, like 3/4 of the carbon emissions produced by that of like a fuel-driven car?
Absolutely, and the more powerful the electric cars are, the more energy they need for their production, potentially increasing greenhouse gases, and the situation is only worsening since Tesla has announced that its Model S vehicles will now be equipped with 600 kilometer range batteries, and its CEO, the famous Elon Musk, has announced the imminent arrival of 800 kilometer range batteries.
Yeah, and these cars they're getting more powerful. There are some trucks now and the Jeep, and they're getting easier to recharge, and every day they're getting to be more and more like regular cars, even if a little more expensive. But with this in mind, is the electric car an ideal solution for like the mobility of tomorrow?
Well, allegedly, the electric car is going to solve the problem of mobility in a carbon-constrained world. All our politicians have a position paper on their website for electric cars, but are we sure that this device is the ideal solution for a green future? Me personally, I really, really doubt it.
I've considered buying an electric car, I'm interested. Two of the advantages are it's noiseless, and then they boast that there's no pollution at all. Since in the media, the expression is that it's a clean vehicle. Is that true?
As usual, despite all the media hoopla, only some of this is true. Not even mostly true when electric cars are assessed from manufacturer to end use, full production cycle.
Well, what about I mentioned the noiselessness of it.
Anyone who's driven an electric car, no doubt, has noticed that it is indeed less noisy than a petrol or fuel car. But the absence of a noise is essentially valid at low speed, and as the noise generated by vehicles on wheels mainly comes from rolling as soon as they go over 30 to 40 miles per hour.
Right, and things that move make noise, like caused by the friction of the wheels on the road or the friction of the air on the car. It can become the dominant components of the global noise. The one coming from the engine becoming like the secondary.
Exactly. Using cars only at low speed only means using them in urban traffic, precisely where cars, electric or fuel, generate other problems such as congestion.
But I don't need to get too excited about something having no noise when it could actually cause some other problems. Like when it's driving really slowly, I've had them come up next to me on my bike and I don't even know it's there. Like that could be dangerous.
Yeah, and electric cars might need to have a bell to warn these bicyclists. Otherwise, pedestrians don't pay attention and get run over. I mean, streetcars in New Orleans are equipped with bells precisely for this reason, and perhaps it gets on the nerves of the people that live along St. Charles Avenue, but that's just the cost of the modern age. That's just the way it is.
I don't want to miss this point. Like a minute ago, you mentioned that there's no local pollution.
Where the electric car is used, the electric car had to be manufactured somewhere, and this entire process has generated plenty of local pollution elsewhere, specifically at the point of manufacture and all points supporting that manufacturing process.
But that's also true of like a regular car.
True. Fair point. For example, for a regular car, we must extract from the underground ores of all kind: iron, copper, nickel, manganese, gold, platinum, and many other metals. And all this generates local pollutions, and admittedly, sometimes it's massive.
Yeah, but I mean, a regular car also uses plenty of electronics with processes that I imagine must generate local pollution.
Yes, and for a regular car, we must, to be fair in our analysis, use plastics of all kind and thus extract oil, plus the battery must also be manufactured, which requires chemical industries, metal industries, and other industries that always generate local pollution, sometimes a little, sometimes a lot.
Well, then there's the end of the life of that car, and now you have this big hunk of junk that you have to get rid of or recycle or something.
And that covers the process, the full product cycle pretty well, ending it on the jalopy scrapyard note. So for a regular fossil-fueled car. But manufacturing an electric car also generates global pollution. As with a regular car, an electric car needed fossil fuels to produce the raw materials used: coal for steel, oil for plastics, gas for the glass, a little of everything to manufacture the paint in the electric car.
When you're making this, car that's supposed to be this future, the savior, you're actually using the gas and the coal just to put all the components in it.
And this putting it all together means components must travel from one plant to another with trucks that for the time being do use gasoline, and as a result, the CO2 emissions that arise from manufacturing an electric car are about the same of what they are for a regular car, which is 5.4 tons of CO2 equivalent per ton of car.
Okay, I like that. I like that you mentioned the per ton. It feels a little more accurate. Like one of the things I think is kind of misleading is that sometimes they brag about them being lighter, and the electric car is lighter and it is less powerful than the gasoline. So the media will state that overall there's less carbon per ton or something like that, or not per ton, but they'll word it where they compare it in the wrong way.
But not per ton. It does not take less carbon emission to make an electric car per ton versus a petrol or fuel car.
Yeah, that's right. And so can we can we frame that in terms of maybe like how the distance it travels or something opposed to weight?
For an electric car that has a, quote, life expectancy of 200,000 kilometers, roughly 120,000 miles, it means that each kilometer generates, for the manufacturing process, 40 grams of CO2. That's far, far from being totally clean.
Yeah, I would say far from it. Let's focus for a moment on the amount of electricity that has to be generated in the manufacturing process of an electric car.
Coal still accounts for most electricity production at 40% of the world production. This proportion rises to 50% for the US and Germany, and even higher for Australia or Poland. And coal, remember, is the dirtiest and most dangerous energy we use. Lignite is the most specific dirtiest coal, which is prevalent in China and Germany. Too bad for those countries. Then gas comes in at 20% of the world production. Gas generates CO2 emissions when burnt 30% less than oil. Still not zero, but 30% less than coal. So fracking has CO2 emissions 30% less than coal production. Heavy fuel comes in at 5%, hydroelectricity at about 15% of world production, nuclear less than 15, wind around 2, less than 2, and solar is not even really on the map.
Yeah, and electricity is mostly produced with fossil fuels. I'm assuming that that's the case in most countries in the world.
But except for France, Switzerland, Norway, Brazil, and Sweden, they're not on the category, and they're doing pretty well in that regard.
Okay, then in the CO2 emissions per kilometer, then they can become close to what they are with a petrol car that has the same mass and the engine power.
And that's a great big picture there. And I hope we can already see in this podcast that any good faith discussion or presentation of electric cars as the new and improved messiah, we must be more comprehensive than what is generally done. We have to look at the full production cycle, world production of electricity, full picture.
Yeah, I mean, at the very least, like when we're talking about this, people need to include the emissions associated with the manufacturing of the cars, in both cases, like the fuel and the electric.
And compare vehicles of equal mass and power, because often the electric vehicles assessed in the media, in mainstream media, are so often compared with standard cars that are heavier and more powerful, which of course gives the advantage to electric cars, which are lighter and not as powerful.
I mean, we'd be on board with the electric car. Like, I just don't want to be lied to. I mean, I feel like I represent most people when it comes to that. So are there any other tricks, whoever you want to blame, the media or whatever, but are there any other tricks in their presentation of electric cars that we should, as consumers, be made aware of?
Be careful that the media presentation of this situation with fuel cars versus electric cars, that they did not compare theoretical calculations or data that comes from prototypes for one category of vehicle with data coming from real life use for others, knowing damn well that real life is never as optimized as theoretical calculations or prototype use. For example, the emissions given by car manufacturers in Europe are 30 to 50% lower to what comes from real life observations.
That difference right there would be a deal breaker in deciding which type of car to buy.
Of course, hence the marketing tricks.
Okay, anything else?
Yeah. For electric cars, they should include in the average consumption accessories that are not used during the test on a sunny day in spring, but all of the rest of the year. This would include heating or air conditioning lights, windshield wipers, and all the small electric engines that are everywhere in a modern car. And lastly, include the full life cycle emissions of electricity generation, which we've already alluded to.
And then I'm assuming that trying to find comparative analysis that do all of the above is far from easy.
Sadly, much of this legwork you will have to do on your own.
Amir, are there any other comparisons that we should know about?
At minimum, I found the following interesting. An internal combustion energy has a yield of 20% on average. It means that the mechanical energy getting out of the engine is equal to 20% of the thermal energy coming from the combustion of oil or gas. On the opposite side, an electric engine has a yield of 80%, which means that the mechanical energy getting out of the engine is equal to 80% of the energy content of the electricity coming in. In both cases, the excess energy is turned into heat.
Okay, so that information right there makes me feel like the electric car is the hands down winner.
Yeah, on a quick analysis, yeah, but not so fast. This is why the analysis has to be somewhat comprehensive, critical. Yes, the yield with electricity is much better, but storing electricity induces a 20% loss of the initial electricity, when for gasoline cars it's basically zero, and for electricity there are distribution losses around 8% from the power plant to the low voltage socket, when they are limited to 2 to 3% for fuel cars, and for a gasoline car the auxiliaries, lights, wipers, and most of the heating in the winter run on the engine and are already accounted for in the consumption per kilometer, whereas for an electric car they run on the battery and they represent 20% of the consumption of the engine on average. And lastly, all included at the final analysis, the yield of electricity is about 50% overall, not 80%.
But still, using electricity is 2.5 times more efficient than using gasoline, like 50 to 20.
Fair point. So, but at the end of the day, it really comes down to how your electricity is produced, which we focus on this podcast thematically with what? Coal, fuel, wind, solar, nuclear, and how efficiently you're getting that electricity. How efficient is the national grid from which the electric cars are getting their energy? Is critical in the base analysis.
Okay, so the electric car is not the silver bullet, but it's a good idea in the context in which it takes place.
Yes. Turning the road transportation system to electricity would require almost half the present electricity generation. Electricity in transportation is therefore a pragmatic idea, as good as the context in which it takes place, you're right on that, and converting all cars to electricity, and if these cars are small, and fed by electricity coming from pretty clean means of production, solar or much more likely nuclear, then it is definitely a pragmatic socioeconomic solution to seriously consider at a national level.
Okay, but to advocate the massive conversion to electricity of all existing cars, with each car being used as much as today, that would, in my mind, it would be a solution that only moves the problem.
Yeah, it kind of kicks the can down the road. Ironically, it could very well be a remedy worse than the disease if the country where it happens produces most of its electricity with coal. And that typically is the case of most states within the United States. Of course, we can avoid the urban pollution due to regular cars, but increase the pollution due to coal power plants making the electricity, which increases global warming, which bears potential threats greater than those of urban pollution. Again, we come back to the base analysis. How the electricity is produced is key, critical, decisive, whether it's from coal, gas, or nuclear, and is clearly a decisive, critical factor on the issue of the viability of electric cars, period.
Okay, so maybe this is the centralist in me speaking, but perhaps the solution is the hybrid car. The hybrid car has both an electric engine and a thermal engine.
And the hybrids are more efficient than classic cars because they get back the kinetic energy when braking to convert it into electricity and use the electric motor more efficiently, while the thermal engine is less efficient. But critically, hybrid cars would not require additional power plants. So yes, you are right. That would be a pragmatic socioeconomic solution to this national problem, say for the next 15 to 25 years.
Okay, and then what?
Man, Jamie, at that point, we have hopefully a new tech framework, a new tech paradigm, and it's someone else's problem, not mine or yours. Due to the environmental impact of extracting rare metals, we really need to be far more skeptical about how green technologies are manufactured. Before they're even brought into service, the solar panel, wind turbine, electric car, or energy-efficient light bulb bear the original sin of its deplorable energy and environmental footprint. We should be measuring the ecological cost of the entire life cycle of green technologies, a cost that should have been precisely calculated but never is. Why is that? When this would allow for less negative externalities and more accurate pricing of so-called green energy products of any kind, and that includes electric cars. But we are so far off from this scenario that is the opinion here that electric vehicles may be technically possible, but their mass production globally will never be environmentally sustainable. This concurs with similar research. The 2016 report by the French Environment and Energy Management Agency, ADEME, finds the energy consumption of an electrical vehicle over its entire life cycle is on the whole similar to that of a diesel vehicle. The report also finds that its environmental impact is on par with the petrol car. In fact, an electric vehicle might even emit more carbon dioxide than it consumes if the electricity it uses comes from predominantly from coal-fired plants, as is the case in countries such as China, Australia, India, Taiwan, and South Africa. Such are the exacting conclusions of research published in the journal Nature Energy in 2018. If everyone in China were to rush to a fast charge station during a peak in electricity consumption when only thermal power plants are able to meet most of this demand, an electric car in China might generate over its entire life cycle more carbon dioxide than a conventional car. This leaves us with a dirty laundry list of unanswered questions. Is the replacement impact of EV batteries, which have a short lifespan, being taken into account? No. Do we know the precise ecological cost of all the electronics and connected components packed into these electric vehicles? No. What about the environmental impact of recycling these mostly still new vehicles in the future? And how much energy will it take to build the necessary electric grids and plants to meet these new needs? Sadly, it seems no one in the green energy business is willing to clearly and honestly communicate on these points. Maybe it's because, like them in the green energy business, don't we all want to believe that we're making things better rather than making things worse? Well, there's not going to be any pragmatic solution until we first assess the complexity of the problem as truthfully as we can and the total cost. So listeners, please get argumentative with your neighbors about today's podcast so that we can then start to solve the problem that once properly delineated, we can then better get on towards a more long-term practical solution. You heard it here on Amir Phillips, American Pragmatist. This has been Amir Phillips, American Pragmatist. If you like the show, please hit like or subscribe. Also, it would be awesome if you went to the website, americanpragma.com. Any support there is greatly appreciated. Thank you so much.